There we are. Thank you, Ed. Nearly forgot that one. So when you have constructed your relational database in a proper manner through the normalized data and hooked all the files together, and as I said, you can have up to 300 referential constraints per file. You can eliminate an enormous amount of that code from your application program. There is code all over an application program that tends to try and check whether this file exists on that record before putting another file on another record, or checking to see whether files exist on a dependent file and deleting them first before you delete the parent file. All of that type of code throughout your entire application can be removed, and it is replaced by a set of referential constraints and unique and primary key constraints, which are built into the database and apply across the board to all clients, not just to the application code itself. So this is one of the significant pieces or significant components of the modernization of a database, a normalization of a relational database to provide the database with massive amount of power and remove all of that unnecessary coding from within the production. So that is the one big thing. It is my second favorite component in modernizing a relational database. And now we move forward, and the next component that to me is the single most important component in creating an intelligent, self-aware database is trigger programs. However, I've got to cover a topic relating to pointers before I can go and move into the topic relating to trigger programs, because pointers are, well, to my mind, a pointer and the philosophy of and management and use of pointers is the greatest thing that RPG has ever provided us with. Pointers are everything. They are so powerful, they are useful, and in the case of triggers, necessary to make things work efficiently. So I have a small section which we are going to deal and just understand pointers. I'm sure that a lot of you have used pointers. This will possibly be revision. I may have some insights that you haven't come across. For those of you that haven't used pointers before, please pay close attention, because they will become the greatest tool that you've ever seen. And to explain how they work is, in a way, once you get them and you understand them, they're easy. But of course, like everything else that's new or unusual, they take a little bit of a learning curve to be comfortable with. So I've drawn up a set of slides to try and explain what a pointer is. Now, this box of blocks at the bottom is in fact a section of virtual memory out of somewhere in the middle of the IBM I. You don't know where it is. Nobody knows where it is, or how big it is, or how the machine actually connects to it, but it is a series of blocks 1 byte per block that exists somewhere in the virtual memory of an application. It could be on disk, it could be in memory, it could be anywhere, we don't know. But that's not important. What is important is that it is a sequential series of bytes, and they can be addressed directly by a system pointer. A system pointer can be, I just get my highlighter. A system pointer is defined by using the star in partially free RPG. Those of you who use the fully free RPG, it's the word pointer, and that is a 16-byte half-word adjusted space assigned to contain a system pointer. Now, just an interesting aspect of that is that 16 bytes is 128 bits. If you sit with your calculator and work it out, and I actually don't think most calculators are big enough to handle this, but if you remember your binary arithmetic from way back, where the right-hand side bit is a 0 and a 1, that represents 1. The next bit in is 2, 4, 8, 16, 32, 64, etc., 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 all the way down. If you do that for 128 bits or 16 bytes, and then you add them all up, I've never done it recently, so I can't actually remember the number, but it is plenty. And that number is, in fact, the number of directly addressable memory bytes available to the IBM I. It's a 28-bit register, which is a massive number of directly addressable memory space. It's one of the things that makes the IBM I such a high-performance machine, because it can directly address, without offsets or any other messing around, it can directly address an enormous amount of space. Right, so your system pointer has an address. Now there are various functions. Sorry, I must do something here because I need to find it. I forgot to open this document of mine before I started this session, so bear with me 1 second. It's my most favorite book. It's called ILE RPG Reference, and I'll find what I'm looking for and then bring it back. Operations, expressions, and functions, built-in functions. In order to address or set a system pointer to an address, one uses a built-in function called %ADDR. You can specify %ADDR and a variable name, and the pointer, so it will be pointer is equal to the address of a variable. And that will place into the pointer the actual address of a position in memory. Now, please understand something about this address function. It gets you the address of a variable, and it makes it available to your RPG program. So it can be used from then on. That address, if I can get back to here, is pointing to a position somewhere in the memory. Your concern is not the actual value of that pointer, because it's too big to play with. But you must understand that it is actually a numeric value and can therefore participate in arithmetic. We can subtract one pointer from another. We can add a number to a pointer to move that pointer down the memory. We don't know where it is, but we can add 10 to move it down 10. So what I'm actually wanting to get to here is that in this little diagram, the pointer that we have, that address, whatever it is, 1C57, etc., 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 points to the 1, the first byte of the section of memory that I have illustrated here. In fact, the address would be set by using a percentage ADDR for field 3. Or such other method of setting the pointer. What I have here on the right-hand side is I have a DSpec for the pointer itself. I have a field, unsigned big integer rather, of a value for a field called offset, and then I have 3 fields. All 3 of those fields, and this is where you've got to understand something. These fields are based on a pointer. They are based on that SPP pointer there. Which means all 3 of these fields exist at the same value of this pointer here. I.e., they are overlaid one on top of each other because they're based on the value of SPP. Field 1, field 2, and field 3 have no meaning, no content, and cannot be referenced or referred to if the pointer has no value, because then the fields don't exist. And I am sure that every single one of you, if you've got involved in working with parameters and all that sort of thing, you've seen the error message, pointer not set for location referenced. I'm absolutely convinced that that is a very, very familiar message with most of you. What it actually means is that you have attempted to reference a field that is based on a pointer which has no value. That's what that particular message actually means. And because all parameters are passed by reference, which is by pointer, that's where the most common occurrence of that error message comes from, is where one field is not passed. The called program or procedure tries to reference it, but because it hasn't been passed, it hasn't been provided with a pointer. So that's what causes that problem. Now, here's a little bit, moving forward, a bit of a mental exercise. I have a value of 83 in offset. So if I add a value of 83 as the offset to the pointer, i.e. SPP plus equals offset, it moves the pointer 83 bytes down the memory and will actually address the A of A, B, C, D. Now, if you go back here, you will see that the 3 fields, only 2 of them are valid. Field 2 is not valid because the addressed space does not contain packed numeric. So if you attempt to address field 2, you're going to get a decimal data error. Once we have added 83 as the offset to the pointer, we have moved the pointer down the memory to the A of A, B, C, D, E, which means that only field 1 is valid. Field 2 and 3 are not valid because that is an alphabetic field. It's a character field. Now, the important thing to understand with pointers is that the address of the pointer identifies a byte in the memory, and that byte in the memory has an offset of 0 from the pointer, i.e. pointer plus offset of 0 equals pointer. It's subtly different from a data structure. A data structure, the first byte in a data structure starts in position 1. Therefore, the offset from a pointer and the start position of a field in a data structure differ by 1. And that is probably the thing that is, when you start working with these pointers, is going to be the most irritating and confusing thing of the whole lot. Is that a pointer points to a byte with an offset of 0. An offset of 1 points to the next byte, whereas a data structure starting at 1 points to the beginning of the data structure. So if you have a pointer that is the address of a data structure, then the first byte of the data structure is offset 0, but byte 1. Now, you can think about that. I will stop at the end of this for questions. Let's move to the next one. If I do another thing, if I do SPP plus equal offset plus 10 as the next statement in my program, it's going to point to that byte there. Or is it? Just look at this very, very carefully, because this is the hardest concept of using pointers to really come to grips with. Once you've got it, and you will never forget it. The first statement that I have here updated the value of SPP so that the pointer then pointed at the A here. The second statement takes the pointer not as it was there, but as it is here. Which means it is already updated. So this SPP here is actually already the original plus 83. And I'm then going to add 93 onto the top of that. Which means I'm not going to be moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which would be indicated by this. But I'm actually moving it 93 from its original position, which is somewhere down here, and I'm not sure where it is. I haven't added it up. So one has to remember that if you change the value of a pointer, that is then its existing value. And anything else you add to that pointer, you are moving forward from that position onwards. Now, this is a fantastic tool for scanning long strings, I mean, it works. It can be used as an array. It's only 3,500 times faster than array processing to use a system pointer. So there are so many things that a pointer can be used for. But one has to remember that if you want to have a base datum point like the one here, then you must make sure that you store that base pointer and use a second pointer to move around your memory. We will be talking later on about user indexes, user spaces, and all of those sort of things. All of these are driven by pointers and can be very, very powerful in application code. So, okay, I did put in the arrow, and there's where it actually is pointing, even though misreading it, you would assume that it's pointing at this field here. Okay, that is just the arrows. And you can see that each one of these three fields would be valid under certain circumstances. When you have got to the last one, which is where the blue X is sitting, be careful. And this is the other cautionary tale about system pointers. If you miscalculate a system pointer and you point it at something somewhere in the memory of your application program where it wasn't supposed to be pointed at, you could overwrite important information within your data definition structures or in your file structures. You cannot point that pointer outside your job boundaries, outside your job domain. It won't let you do so. But inside your job, inside your PAG, you can actually corrupt sections of the PAG if you're not very careful. So it's worth, I use the debug, interactive debug on RDI, and whenever I write code, I step through it with the interactive debug, and I check that all my values are pointed to correctly, and so on and so forth. Interactive debug, greatest thing since sliced bread. Right. Are there any questions about pointers? Or any sad stories or good stories to tell me about pointers? You don't have to type in the chat box. You can also unmute and talk if you feel inclined. I don't mind either way. All right. It seems as if we're all either totally familiar with pointers or haven't a clue what questions to ask at this point in time. But remember, the next topic, we've seen that picture before. The next topic we are going to talk about is my favorite subject of all time. It is the DB2 relational database trigger programs. In fact, trigger is not quite the correct word. It's triggered, because the programs that we are talking about here are triggered by the relational database management system on a particular event. Triggered programs can be written in any language you choose, as long as, in my case, it's RPG. They are high performance because they run in the memory pool, in the machine pool, under the operating system priorities. And as a result, they are highly optimized. And we will talk about the difficulties that can occur if you overestimate the abilities of a trigger. But triggered programs are an integral, significant part of a modern database and properly utilized within the database, they can reduce, and you will not believe this number, but it's true. They can remove between 40 to 60% of all the lines of RPG code in your application. Because 40 to 60% of the lines of RPG code in your application have to do with one of two things: database validation or database synchronization. In both cases, a combination of triggers with constraints will remove between 40 and 60% of the code that you currently have in your application programs. Of course, having done that, you have 40 to 60% less lines of code to test, which means your testing is a lot easier as well. And you have 40 to 60% less lines of code to maintain, should you wish to upgrade your application. So the knock-on benefits are extraordinary. I cannot talk enough about triggers. And in fact, this is exactly what I'm going to be talking about at Wisconsin in March, the user group there, because they are my favorite toy of all times. Right, let's proceed to look at where they fit into the whole picture. You have a program, which is a program within an application. It's a client program, and then that program requests or asks for service from the RDBMS, the management system, relating to a table. Now, the RDBMS, of course, has access to the jobs PAG, where the file definition tables are stored. And so it can determine from the PAG, and I should have had the slide, but I think you can probably remember it, because the table definition contains the trigger definitions. So the RDBMS will examine the PAG, look for the file definition table, and determine whether, in fact, there are any triggered programs involved in this particular request from the program. If there are, the RDBMS will do a number of things. The first thing it will do, it will apply the requested insert, update, or delete to the table. It will then look and see which triggered programs have been defined. And it will pass a call to the appropriate triggered programs in a specific predefined order, and will process the responses from those triggered programs before actually finally returning control to the application program. So there's a lot that goes on between the request to insert a record, for example, and the actual return which says your record was successfully inserted. But that's where it happens. It happens within the relational database management system. And the definitions of those triggered programs are defined with the table. I'm going to pull this in. Little green screen, which I'll probably make bigger so you can see it. Add pftrg is the command that will allow you to add a trigger to a file. That is the command that allows you to do it. So, getting rid of that and going on to the next slide, I want to talk about what events can be triggered. And this is a table that illustrates the events that can be triggered. There are three categories or classes of triggered events. There's the before class, which is before the update is actually confirmed to the table, i.e. insert, update, or delete is confirmed to the table. There is the after class, which are used and called after the insert, update, delete has been applied to the table. There is also an additional triggered event there called read, which is called, if present, by the after class of triggers. I've used that once, and I'll explain its use in a little while. It's actually not used very often. Then with version 6.1, we had the third class of trigger being attached. It's an instead of trigger. Insert, delete, and update. And it is applicable and is usable only on SQL logicals. It is a SQL set of triggers. And for the purposes of this session, I'm not going to discuss the instead of triggers unless there's a very, very specific request for it, because it's SQL based and there are other ways of achieving the same result without having to learn a completely new skill set. A maximum of 300 trigger programs are allowed per file. Actually, if I'm not mistaken, that one has also gone up. I think it's about 2,000 now, if I'm not mistaken. However, discussing whether it's 300 or 2,000 is rather irrelevant, because I promise you, you're not going to add 300 triggers to a file, let alone 2,000. Let's have a look at what happens when a client application requests an action on a table. Now, it can be an insert, a delete, or an update, or in the case of an after trigger, it can be a read as well. Before the update to the table, or the insert, or the delete is actioned, if a trigger has been defined for that class or event or for time and event, if you look at it here, you will see there's a trigger time, before, after, and there's a trigger event, insert, update. So that's where you create a link to tell the relational database management system that you are attaching a program, there's the name of the program and its library, to a physical file for that particular time and event. So you, as the database architect, attach triggers to files, and those triggers point to a program. I will talk about some of the other parameters just now. AO allows you to define these triggered events and manages them for you, i.e. it applies them and manages them for you in order to keep the database correct and properly defined. The one thing that is a high-risk issue with triggers is they will be called if the definition exists. But if somebody disables or removes the definition, then whatever that trigger was supposed to do is not being done. So the actual attachment of the trigger to the file is a very important issue. Let's have a look at the before class. Before insert. If a program is attached to the before insert event, it will be called if the client attempts to insert a record into the table. And here I'm talking about every client. I'm not only talking about your application, your production system. I'm talking about every single client, because the relational database management system and its associated triggers care not one little bit for the program or client that is requesting the activity. The only thing they're interested in is the file on which that activity is being performed. So it works for every client, including DFU, DBU, and any SQL client you can think of. The same thing will happen for the table every single time. So if a program is attached as a before insert, there, then before the insert is finalized for the table, control will be passed to the program that is defined for that event. If the event was a delete and there was a program, sorry, mouse writing is not my best skill in the world, or mouse drawing, shall I say. And of course, you also have an update. So whichever is the event that has occurred or that has been requested by the client, the program associated with this particular before insert, delete, or update is actually called. Now, I usually create a single program as a before trigger, BT, for each one of these events. So each one of these events is linked to a single program. I have a single program that caters for all three before time events. And there's a very, very simple reason for that. Before triggers are primarily designed to validate information or data before it is allowed to go into the table in the database. That is the typical requirement or action of a before trigger. And of course, the validation that is performed by that before trigger is, generally speaking, exactly the same, whether you do an insert or an update. So instead of having those business rules written into two different programs, we write the before business rules into a single before trigger program that is attached to all three events. You'll actually find that the delete event is more often than not attached, because there's no validation that needs to be done with the delete event. If you have your referential integrity correct, you don't need to check to see whether the dependent file has records in it. The constraint will do that for you. So the more common is to have a before trigger program attached to the insert and the update events. But occasionally there's a need to attach one to the delete event as well. And I will show you examples shortly of trigger programs and how they handle this request for a before, update, insert, or delete. Once the before trigger, if applicable, because if it's not defined, it's not called. But once the before trigger has been called, it can respond in one of two ways. It can respond without comment. If a before trigger responds to the database management system without comment, then the database management system proceeds with the next step, which is to insert, delete, or update the record on the table. But not to commit it. Then it will go and look for any after events. Insert, delete, or update, or read. If there are programs attached, and I generally, once again, have a single program for the after trigger events, and there might be attachments again. Read is very rare. It's used on a very, very specific occasion, when you want to suppress a user's ability to read certain records out of a file. So the after event will essentially call an after trigger. Now, an after trigger, whereas a before trigger is designed to primarily to do validation of data coming in and to provide proper defaults and to add user ID and last change date and all that sort of stuff. That happens before you finally insert, update, or delete, whereas the after trigger is much more concerned with the synchronization of the database files. And an example of this would be if you had a file which was a summary file of a transaction file, i.e. the transaction file was summarized by customer, by month and year, for example. It's a small example, but it's fairly common. We mostly build that summary file at day-end batch run by reading all the transactions for the day, summarizing them, and updating or inserting them into the summary file. In the case of using triggers, an after trigger would in fact maintain that summary file one event at a time, which means that you reduce the need for doing that during a batch job at night. Now, let me tell you, the performance is beyond reproach, and quite honestly, to do this type of thing, users will not even notice a performance degradation within the database. It just doesn't happen. So the after triggers are generally synchronization triggers or audit information collectors. And this is important. You can also, I know that a lot of you probably process journals in order to extract information for audit reports. That is time-consuming. It requires a complex journal management procedure. And if for some reason one journal receiver goes missing, you lose that information. So rather than use journals, I use after triggers. I call them change collectors. It's a specific type of after trigger that collects changes to the files in the form I want them for my audit reports, or my analysis, or my tracking. And of course, you can switch them on and off as you want, if you want them only to be temporary. So those are the two, the before triggers, mainly for validation, the after triggers mainly for synchronization. But, and this is a big point, it's not limited to that. I have used before and after triggers for some of the most extraordinary things that are an easy way to satisfy a requirement that a customer has or a user has without going into long, complicated batch or interactive processes. Because remember, a before and an after trigger already divides itself up into insert, delete, update. And it is a single record process, i.e., you don't have to code for multiple records. You code a trigger for single record action because a call to a trigger only processes one record. Okay, so before we move towards looking at some actual examples of triggers and finding out what all the bits and pieces of triggers are, I am going to move back to this slide again because I need to keep you grounded into where we are with the database modernization. We have done the DDS to DDL where necessary. We have normalized and set up our constraints within our physical database. So we have already gained a huge benefit, and we have eliminated a lot of need for code in our application program. The next thing which we are talking about now, we're not talking about this one now. The logical database will assist us in the way we look at the physical database, but we will talk about that later. We are now talking about the trigger programs. Now, the interesting part about the trigger programs is they are below the database. They're not above the physical database. They're not by the logical. They're not with the IO service, and they're not with the application. They are program procedures or modules or whatever that are only associated and only interested in the physical database. That is where they sit. So they are intended to provide the database with intelligence, with the ability to make up its own mind as to who can and cannot mess around with the physical data in the database. The others, of course, IO services, we'll come to, enterprise services, application code, and the user interface. By the way, at this particular point, coming to the user interface, we do have, I think it's 4 sessions, if I'm not mistaken, where Nathan and/or Kendall Anderlin, who are the authors of a product called 1 Point Portal and Developer Toolkit, which is in fact a user interface creation tool. 4 sessions of later on towards the end, they will be demonstrating and explaining and showing you the product, which we believe is the best way to create your graphical user interface. So they will take the podium a little bit later on to take you through the interface, the modernization, which of course means that we're looking at modernization in its whole picture, from the top to the bottom. All right. So this is now the picture that shows you the constraint plus the triggers. Now, I will be coming back to explain some of these triggers to you, but I'm going to now look at trigger code and explain exactly how you can construct trigger code. And then we can come back and look at these triggers and see what we would put into these triggers to make our little database work for us. Okay. I have a file A. Which is really a rubbish file. I had to create it in order to allow me to compile the triggers, because a trigger program references a file definition, and therefore you need a file to compile it. I usually, in fact, it's pretty much 100% on all my databases. Every time I create a physical file, I will create at least a before trigger, because it's unusual for any physical file not to require some fields of validation. So normally a before trigger is always created at the same time as the file, and of course its constraints. An after trigger less frequently. An after trigger is put into the database for specific purposes. So this is the file that I created to support my trigger. Now let me find the one trigger. I did two triggers. Okay. The B0 trigger is a fully free trigger. Just with a quick unmute, how many of you are using fully free as opposed to partially free RPG? Okay. How many of you are not using freeform RPG at all? Okay. So we've got a bunch of people who are using what I call partially free. It was the version available at 6.1. And when they went to 7.1, they gave you the fully free RPG, which also allowed you to do the top end of RPG, the definition specifications in a freestyle form, i.e., they implicitly gave you permission to mess up the beautiful, organized, columned, and structured RPG that I've been so used to. So I wrote this trigger. You will be being given this trigger program, by the way, sometime later, to base your own triggers on. So I wrote it both ways. Unfortunately, I still have to stick to the partially free method because I'm coding AO at version 6 in order to support users that have version 6. As a result, I can't code my programs using the fully free format, but I've created both so I can show you either. Also, it's to prove that I actually can modernize myself and use the modern methodology. But I stress what's extremely important is if you do use the fully free version, please lay it out nicely so it reads decently. Don't just go crazy because it's freeform. Please don't make a mess of your programming. The neater and tidier and easier to read, the better. So just because it's free, There's no excuse for being ugly. And that's a lesson from me. Which one would you prefer me to use? The D-specs or the fully free? I'm sure you can all read the D-specs, so I will use the D-spec version just to be sure that everybody is on the same page with me. All right, a trigger program is a program. It is a callable program. It has to be a callable program. Can't be anything else. Can't be a procedure. It can't be anything except a callable program. But it can be a C program. It can be a CL program if you really want to do CL. And it can be any other type of program. But as Ford once said, you can have any color you like as long as it's black. In my case, you can do it with any language you like as long as it's RPG. Let's have a look. When the relational database management system calls a trigger, now this is applicable to both the before and the after triggers. It passes two parameters. And the two parameters, the first one is a variable size parameter, and it can change from quite small to quite big. And the factor that determines how big your first parameter is going to be is in fact the record length of the file that you are writing this trigger for. Please, you can write one trigger for many files. And in fact, we will look at an example of a particular trigger that's written for a particular purpose that is attached to many files. But I believe that to keep it neat and tidy and to avoid masses of unnecessary conditioning, you write your trigger to match your file. i.e., the trigger file combination is a one-to-one combination. The first parameter, I use a like DS here, and it looks like that, which is a standardized trigger program parameter list. You see it in every single trigger call, before and or after. Not mentioning the instead ofs because that's very different. The second parameter is an integer, signed integer, that tells you how long the first parameter actually is. Now, because I write one-to-one, I've never used the second parameter. I've never found any need to. So I know how long this parameter actually is. And let me explain the parameter and its details. There is a red book which explains all about triggers and how they are set up and how to use them. And you're more than welcome to go and look it up. I will give you the title later. But hopefully with the code that I'm going to give you, plus these recordings, you won't need it. The standardized parameter list consists of 95 bytes in the fixed portion of the parameter list, and following that 95 bytes, a variable number of bytes of variable length data, depending on the size of your record and the number of fields in your record. And I will go through and show you exactly what those are. But the first thing, the first parameter that you get, or the first three, are significant. Physical file name, library name, and member name. That is where the trigger call came from. And notice very clearly, there's no mention anywhere in this parameter list of the program that issued the call or created or initiated the event. Trigger programs and the relational database management system are completely and utterly disinterested in the program that made the call. If you want to know which program made the call, you have to find that out yourself. But standard trigger terminology says I need to know the file, the library, and the member name that the call came from, and that's all I'm interested in. The next two parameters are the event and the time, i.e., is it an insert, update, delete, or read is the event, and the time indicates whether it is a before or an after. So I'm just realizing I don't know where my example after trigger's gone, but we can make one. It's not a problem. You then have a commitment lock indicator, and this indicates to you whether the actual record that this trigger is all about, because remember the trigger is called on a record level event. And this commit lock indicator tells you whether that record is locked for commitment control or not. There are a couple of bytes reserved there, probably for future use. There's the coded character set ID of the file and the record that you're currently being processed. There's the relative record number of the file, of the record in the file. So you have a relative record number as part of the parameter list. And then you have a reserved of 4 bytes, again possibly for future use, who knows. It might also be to align the structure to a particular half-word boundary, because if you remember I said pointers are based on half-word boundaries. So there might be, when you see a 4-byte reserved, it might mean that it's positioning it to a half or full word boundary. Right, now we get, and I'm going to use, we get a set of 4 fields. These fields are related to the old or original record for this particular event. They are only applicable for a delete or an update, because an insert doesn't have an original record, because there was no record of that key on the file, and an insert does not have an old record. But a delete and an update have an old record. These 4 fields are exactly the same fields, but they contain information pointing to the new record. And of course, there's only a new record for an insert and an update. An insert doesn't have an old record, and a delete doesn't have a new record. So what you're getting here is you're getting both. You'll have both old and new for an update. If the old offset or the new offset is 0, it means that you haven't got an event that has that record, but you would already know that from here. because that event there will tell you whether you've got an insert, update, or delete. But these four fields here and the 4 fields here do exactly the same thing. The first is a number. It's an integer, it's a binary number, and it carries the offset from the first byte of the parameter to the beginning of the old record. Now, at this point, I'm going to say specifically that if I lose you, please unmute, shout at me, send me a message, or whatever it is, because this is critical to understanding the operation of triggers. And this is where the pointers integrate with the whole triggers. You cannot manage triggers without using pointers. This is the numerical offset of the first byte of the old record from the first byte of the parameter list, which is byte 1 of PF name. Okay. The new offset is the numerical offset to the beginning of the new record from the beginning of the parameter list. The old offset, new offset, take you to the beginning of the old record or the new record. I'll show you how that's done in the code just now. Old length. How long is the old record in bytes? And new length is how long is the new record in bytes. Now, it is highly unlikely that those two numbers are going to be different, unless the old length is 0, because there is no old record, or vice versa. Then we have here that record, that field, old. Now I'm going to spell this out in full. This is my shorthand. Old null byte map offset, and of course the new null byte map offset. A little bit of explanation is possibly necessary here, because RPG and the IBM I never really supported null-capable fields in the old days. The support for null-capable fields was built in and added to the whole evolution of the operating system. Oh, I can't remember exactly when it happened, but it's more recent than the beginning. And internally in an RPG program, (1992-93), I was told, was when the support for the null byte fields was actually added. A mine of information, Marinus, you are. Now, the important thing to understand that a null field on the disk occupies no space. I.e., if the field has a null, it's not there. It doesn't exist. But within an RPG program, and this is very important to understand because it applies to variable length fields as well. Within the RPG program, the null fields are assigned their defined length. I.e., if I have a 5-byte character field that's identified as null, those 5 characters don't appear on the disk. But in any RPG program that's compiled over that file, there will be 5 spaces reserved for that null field. It's important to understand that. So within your program, there is 5 spaces, which will be spaces. If the field is null, that field will carry 5 spaces. No question. If you test it, or if you look at it with a debug, it's got 5 spaces in it, and yet it's a null field with nothing in it. Every null field, every field in a record in the database carries a null byte indicator. The null byte indicator is used to indicate whether the field is null or not. And it is used within RPG programs to determine whether this field of 5 characters is actually 5 characters or it's a null. And the null byte map carries 1 character or 1 indicator for every single field in the file. So if your record has 20 fields rather, the null byte map will contain 20 characters. Each null byte indicator is associated with a field, and if you use, let me find the appropriate built-in, where is it? Here it is, here. In the built-in functions, null indicator, null end. To query or set the null indicator, you can use this within RPG to take a 5-byte field that has characters and switch on the null indicator so that when it gets written away to the file, it gets written away as a null. So within RPG, you can test or set the null indicator to control whether the value on file is a null or not. But internally, in the RPG itself, it carries the full length of the field. And so what you have here is the offset to the null byte map for the old record, and you have here the offset to the null byte map for the new record. And of course, you have the new length. That's the old null map length is the length of the old record null byte map, which is also a count of the number of fields in the file. That's a useful kink. You can use that to your own advantage quite often. And this here is the pointer to the null byte map offset for the new record, as well as the null byte map length. So now you can see why it is that this parameter is of variable length, because the length of the record and the length of the number of fields in the record will determine the total length of the parameter. I very seldom use the null byte indicators because I don't often use null capable fields in my databases. And I think legacy systems, you will have very few null fields in your legacy databases. In new SQL databases, every field will be null capable because that's the SQL default, unless you actually specify otherwise. So check your databases for that and make sure that actually the null value is worth having, because it does create processing and management complications if you have nulls all over the place for no reason. Okay, so how do we do this? Now I'm just going to use the double X toy here to eliminate some of the stuff in between for the moment, because I want you to see exactly how we manipulate and utilize the pointers within this trigger to get our hands on the images of the before and after records. Remember, the old record is actually the before image of the change. The new record is the after image of the change. So you have a before and after image of an update in every call to your trigger program. So we need to get our hands on it. We need to map it to the record we're dealing with so we can do what we want to do with it. So the trick here is very simple. You create an original pointer, which over the years I've abbreviated to OP. Stands for original pointer. If you are one of those people who really likes to write essays in your data names, you can call it original pointer. It's a standalone field and it has the asterisk indicating that it is an SPP. It's a system pointer. Then we specify the O record, which is old. And the reason why it's so short is quite simple. Externally described data structure, the external name is file A. This structure is based on OP and it's qualified. It's a qualified data structure over file A and it's based on the OP or on the old or original pointer. Exactly the same combination occurs here. We've got a new pointer and we've got a new record externally described on file A based on NP and qualified. The reason they are qualified is because being based on exactly the same file, they will, as data structures, have exactly the same field names. And in order to differentiate between an old and a new field, you need to qualify at least one of them. I prefer to qualify both. That means when I refer to a field, it's N dot or O dot. I could also put in original record in place of the O, and I could put new record in place of the N. Then I would have to qualify them by original record dot and new record dot. And because they're not the same length, they make it difficult to read, and I don't like that. That's me. And so that's why they are shortened. You can make them as long as you like. But rather than just qualify one, I've qualified both so that I can identify in the rest of the code while I'm processing, I can identify which original or new record I'm referring to. In addition, by the way, this, like DSP1, this is P1, which is a template data structure carrying the layout of the parameter list. If I use a P with a like DSP1, that automatically qualifies this P as a qualified data structure. So if I want to refer to any one of these field names in the rest of the program, I refer to them as P dot. So I'm almost self-documenting it by simply qualifying these things. So P dot is a parameter, N dot is a new record, O dot is an old record, original record. Right. First thing I do that's important in this aspect is I set PP. There's PP. It's defined as a standalone system pointer, and the PP, by the way, stands for parameter pointer. And I set the parameter pointer to the address of P. P being the parameter, i.e. I'm setting PP to actually become a value pointing to the first byte of P, which is the parameter. And I do it that way because I now want to play with the pointers. I want to create other pointers, but I do not want to corrupt the parameter pointer, which is pointing to the beginning of my parameter list, because I might want to use that to recalculate something. So I create a PP as a base pointer to the beginning of the parameter list, which is PI, parameter interface. It's that P there. Right. Then, if the event is a 1, remember this is a before trigger. My naming convention here is file name underbar B, because it's a before trigger. And then it can be B0, B1, B2, depending on what trigger it is. You can have the number as big as you like, but that's my standard naming convention for triggers, before triggers. File name underbar B. So here I already know this is a before trigger, so I don't need to test the time parameter in the list. I know it's a before trigger. Don't need to worry about that. But I do need to know what the event is. If it's an insert, and this is the trick here, I set NP, which is the new record pointer, which is that pointer on which the new record is based. I set new pointer to be equal to PP, which is the beginning of the parameter list, plus the new offset as provided to me in the parameter list. So I set the new record pointer. So NP then gets a value which immediately overlays this data structure onto the new record, which has been passed to me by the database management system. So N now has a complete picture of file A. It's a data structure over the new record in file A. Now, because it's an insert event, there is no old record. I don't bother to set the other pointer. The delete event is exactly the opposite. The delete event only has an old record. So I set the old record pointer to be PP plus P dot old offset. And that means that the O record or O structure is overlaid over the space containing the old record. Now, you can see from this, and event 3, which is the update, I do both, because I have both an original record and a new record, and I might need to address them both. So you can see from here that what is being done, I don't need to know where these things are. I don't actually need to know anything. I just have to manipulate the pointers to address the correct space that's been given to me by the database management system. Right. So that is basically how the skeleton, this is the basic skeleton of a before trigger. How it comes to the conclusion as to what it needs to do. Now, I have 3 procedures within each trigger. I have a default procedure, I have an insert procedure, actually I have 5. I have a delete procedure, and I have an update procedure, and then I have a validation procedure, which of course only applies to inserts and deletes, and updates rather does not apply to deletes. Now, these procedures are specifically customized to handle certain things that are needed to be done, or possibly needed to be done by a trigger. I'm not opening this. I don't have to worry about that at the moment. That we can talk about later. So this selection, this select group actually is where the trigger does its processing. Let's have a look at it. The first thing in an insert or a update event is to evaluate and process any default values that are needed. Now, I have a default parameter procedure here. It's used to check for and provide any necessary default values to field columns not correctly provided by the application code. This is an example. The new journal name is a blank. I want to make sure that if it wasn't filled in properly and was left as a blank, the new journal name must be changed to star none. It's an example out of one of my triggers. So we are setting the defaults. Using the default procedure. It's done in the insert event, and it's done first in the update event. Reason why it's done first is because it may impact on your validation if you haven't yet set up the defaults properly. Right, then for each of the events, we have a special procedure, insert, delete, update. These are procedures that are provided to do specific validations or any other specific actions for an insert, an update, or a delete. Not often used. The one thing that I do use often is on the insert, I might want to force certain fields to be blank. Want to insert a change timestamp or a change user. I might also, in an update case, there may be a field, and this often happens when you're using sequence numbers, where you don't want to allow the application to change a sequence number. A sequence number is assigned on insert, and you want not to allow the sequence number to be changed by anybody thereafter. Happens quite often. And the interesting code that you put in here is you would say new dot sequence, new dot sequence is equal to old dot sequence colon. Now putting that statement in the update procedure will make it absolutely certain that nobody can change the sequence number of a record. Nobody. Not anybody using any client at all. Nobody. Because all that happens is every time that this thing passes through this trigger, it takes the original sequence and makes it the new sequence. So if you've changed the new sequence, it simply overwrites it with the original sequence. So you can lock out any changes to that. You can do things like you can do exactly the same thing if you want to make sure that you don't allow people to change the creator's name or the creation date. If you want to control and create very serious business rules and business validations, then this is the sort of thing you can do in a trigger. So you have, I'm going to take that out because it's not supposed to be there, but you can have specific insert, delete, and update processing that the trigger will do. It might be validations, it might be corrections, it might be adjustments. Having done that, the last thing you do is you validate. And now you have a validate procedure where you now write in your validation rules. Now this point, you can see, these are examples. There's a file type that I have in AO. I'm checking to see whether it is one of those values. If it's not one of those values, it will turn an error indicator on. I will explain this bit of code in a short while. But it will turn an error indicator on short while, or maybe next on Thursday. If the file type does not conform to that list of valid values, it will turn an error indicator on. In this case, if number of members is negative, was a test. I mean, that's an example. Turn the error indicator on. Okay. So that you have indicated an error. But, and this is the very, very, very important thing. Whenever you discover an error in a trigger program, you must send a diagnostic message to the database management system, telling the database management system what the problem is. This is very important, because if you do not do that, if you just signal to the database management system that there's an error, and you do not explain what the error actually is, then your poor user, and we'll get to the point where this comes back on the user will never know what the problem was. The user will know there was an error, but will not know what the cause of the error was. So that is why we return, this is a call to a procedure. It is a set of error handling procedures, which I will explain and provide you with working copies of the error handlers. It sends a diagnostic message of that number from that file, and this is the variable that goes along with the message to say that this is a file type error, except that's not correct. That should actually say number of members, because this is a number of members error. That is a file type error. Horrible cut and paste. You know as well as I do that cut and paste can bite you badly. I'm going to save that so I don't get embarrassed by the next lot. So these are examples of validations that can be done on the new and or the old record. You'll notice this is checking the new file type. This is checking the new number of members. Generally speaking, you will be checking the new record, not the old record. However, in some cases, if a business rule, for example, says that your price increase may not be more than 10% of the original price, that's a business rule. You can calculate that here easily. And you can issue an appropriate diagnostic error saying that your price change exceeds the maximum allowed of 10%. That'll pitch up on the screen at the client's end eventually. We'll get there. But the important thing is the diagnostic error messages are issued by the trigger program telling the database management system what the cause of the problem was. And at the same time, as we issue the diagnostic, we turn on an error indicator, which we will see just now. So having completed the validation, and the validation may involve chaining to another file. It may involve calling another procedure, which does a complex calculation through 62 files in the database, and eventually comes up with a yes or no. It can be anything that your imagination or the business rules require. And anything that impacts the validity of the data or controls the validity of the data that is being placed into this database file should be checked right here in one place and one place only. Remember, the triggers are applicable across the board. Every client that tries to touch this file will get any changes passed through this validation. So your business rules become consolidated here in one program, in one place. And once they've been properly established, they never have to be tested again. And it doesn't matter what you do to change the program, they will always apply exactly the same consistent tests every single time. So that's the benefit of the trigger-based validation. Now, it's not only validation you can do. Your imagination can go crazy. And I'm going to now open up this section that I had already hidden away, because there's a couple of things here. Okay. This section here are calls to my various error handlers. I'll talk in detail about the error handlers. Error handlers are really, they mimic the way the operating system percolates error messages, moves them up the call stack. It mimics the way the operating system has been sending messages right since day one. And it is the best way to handle triggers. ERR10 sends a diagnostic message. All these procedures use the standard system APIs to do these jobs, but they just hide the complexity from the trigger and make it as simple as possible. ERR11 sends an escape message. These 3 and 5 are move and resend and move diagnostic and escape message. Generally, those 4 are the ones that are used most. But when an error indicator is turned on by the validation routine, we get to this point. Now, I'm going to talk about legacy just now because this is a very specially designed trigger for a particular purpose. But until I've actually got through the basic purpose of a trigger, it's not going to make much sense. But if there's an error, i.e., if one of the validation procedures turned on an error indicator, and of course, if there's 16 errors, you might have the error indicator turned on 16 times, but that doesn't actually matter. What happens is we use error handler 05, which percolates the diagnostic messages and the escape messages up to the caller. Now, the caller is the RDBMS, is the Relational Database Management System. Remember that, and remember that very clearly. Let me see if I can just illustrate this again. That the caller of a trigger program is the RDBMS. It's not the program. It's not the client program. It's the RDBMS. So this error handler 05 percolates all diagnostic and escape messages from this call stack message queue up one level to the Relational Database Management System. Then we use ERR11, which sends an escape message. That is the escape message it sends. It's predefined in a message file from the error message file, and it carries a variable of the trigger name. That thing actually says errors have been found in trigger file A underbar B0, and that is the message that actually should appear at the bottom of the user's screen. All the diagnostic messages will be above it in the job queue, exactly in line with the way the operating system does it. You get an escape message at the bottom, and then you get the diag messages stacked up on top. So a user can click on that, go into the job log, and it can see all the diagnostics, or you can use the page up, page down key on the message line at the bottom of the screen, and you can page through all the diagnostic messages. Did I say job queue? Message queue. It's the call stack message queue. And he can scroll up and down, depending on whether you're using a display file. If you're going to use a display file, you must use the message file facilities of the display file. UIM User Interface Manager, or there are other techniques which you will see with the one-point portal as well, to get hold of those messages and display them to the client. Okay. Now, if I return an escape message, ERR 0035, the Relational Database Management System will percolate all the messages that I've sent, including the escape message. It will percolate them up to the calling program. So what you're doing here is you are passing the messages to RDBMS, and then once RDBMS receives an escape message, it will pass all those back to the calling program, and it will cancel the update, insert or delete, because having sent an escape message to the RDBMS, what this trigger is actually doing is telling RDBMS to abort the event. That's it. If the trigger sends an escape message, the event, whatever it is, insert, update, delete, the event is aborted. And what the client will see as the final message will be whatever you've put in there. So not only do you control whether the update can or cannot go into the database, but you are in total control of what messages and the context of those messages and the content of those messages that the user will actually see as a result of the trigger. I'm just trying to see whether that's the wrong one. No, it's not. I can use this one. No, can't. Sorry, I'm muttering to myself. I must use another panel. This panel, just to show you, AO has a feature, work with message files. There's the error message file, and you can look at the messages. Now, the reason why AO, this is AO's message file set, error message files. And what was that? ERR. So we can filter these. 0035, I think, was the one. It's not there. 0035. Of course, I haven't imported these because these are in the infuriating. These are in the development section. Let me a little bit of patience, please. I will get there. Let's see whether. Ah, yes, there they are. But I don't know whether there are any. No, there are no ERRs. Messages can be defined within the error message file. They can be exported into the system. The reason that I've put a message file handler into AO is specifically because you can filter by text. So you can, for example, find all the error messages that contain trigger. Oh, there it is. It's actually AOF ERR in my world. It says errors encountered in trigger program number 1, see job log for details. That's the final escape message. But there may be a lot of other messages. Here's one that you can build. The field *1, which is the variable, may not be blank, etc., etc. So you can customize the wording of all the error messages that you're going to be presenting to the user. So the trigger can communicate quite well because you're in total control of what the trigger actually says to the user. Okay, we've got about 10 minutes, so I'm going to explain something here. Trigger programs, if they're written properly and they're written as they should be, i.e., that is to abort an update if it doesn't conform to the business rules that are written into the trigger, is all very well. But at the time that one is beginning to apply triggers to your database, in the process of collecting your business rules and making them valid by putting them into triggers and attaching them to files in your database, your legacy systems, your legacy applications have not at that stage been customized or converted to handle the error messages that get sent back from the triggers. They obviously will need some sort of, first of all, you will need to strip out all the validation from your legacy programs because you don't need it anymore. And secondly, they will have to be modified to handle this percolation of error messages up the call stack. And this takes time. In fact, in some cases, some application programs may never be changed, although one hopes you get to that point where they're all handling it properly. And so this trigger has a very special variation on it. I created a utility server, a utility program, which again I will make freely. In fact, I think it's in our open source environment. This utility is designed to go and look at the call stack. It goes and retrieves the call stack entry that was active at the time the call to the trigger was made. Remember I said that the trigger's not interested in the program at all. And if you want to know about the program, you have to do it yourself. Well, this is how. You put into this utility services, you list the libraries that are considered to be your legacy libraries. And when this call is made to check legacy, there. It calls this procedure, which retrieves the call stack, looks for the current entry in the call stack, and checks to see what library or schema it was called from, or it was executed from. If that schema was in your legacy library list, one of these, then it will assume that the application is a legacy application, is not designed to handle the full function of a trigger. And it will return an indicator saying that you have a legacy program calling this trigger, and it will return the program name that it found, the legacy program name that it found. So this utility is the utility to check the call stack and to find the program that issued the call, determine whether in fact it belongs to your legacy applications or your newer applications, and to indicate on return whether it's a legacy indicator or not. So the trigger uses that to determine whether the call came from a legacy program. Now, the advantage of that is you can now customize the reaction of the trigger. You can still build all the validations in the defaults and the inserts and everything else into it. But when you get to this point where there's an error and it's not a legacy program, i.e., by not legacy, it wasn't in that list of libraries, therefore it must be a new program that has been modified to handle errors from the trigger, we then deal with it in the normal way. Okay. So we send, if it's error and not legacy, we send out the escape message and the trigger handles itself in the normal manner. There's something missing from this program, which shocks me. Because there should be... Oh, no, I lied. There's nothing missing. What I said here is if it's an error and not legacy, deal with it in a normal way. Otherwise, don't do anything, because legacy errors are logged at validation and do not generate a final escape error. And I will show you that here. In a validation, if this field, for example, contains a value that is not in this list, we will turn the error indicator on. But if this is a legacy program, we will collect the error message, which is the same as this one, but we will call a special server to log the error to an error log file. Now, I'll have to pick this up on Thursday and carry it forward, but the log file will then log the error that was encountered, but will not issue the escape message to, as you can see, if it's error but it's legacy, it will just drop through and return. So it will not issue the error message. Therefore, your legacy program, pardon, that hasn't been designed to handle trigger errors won't fail. But the error will be logged onto the log file for reference so that you can look at it, because it'll tell you, first of all, that some legacy programs are actually violating or allowing errors that are, or data that is not valid through. And that means you need to investigate those. You need to find out what the problem is. Are your business rules incomplete, or are your programs need updating? And of course, if you update the program in the philosophy of when you touch, you fix, you would then go to the program, look for why it's allowing errors through, fix it, and get rid of it, so that it can actually react properly to the triggers. Then what you do is you move it from its current legacy library into another library that's part of your application, but is not in the legacy library list that is here. So you just simply move your program into another library that's not in that yellow list, and it will then be treated as a program that can handle the trigger errors. And this is the low-risk method of applying triggers to your database and getting it to log inconsistencies that will allow you to approach the problems, deal with the problems, and then correct your applications to use the triggers correctly. So that brings us pretty much to the end of tonight's session. I've only got about halfway through this. There's a lot more talking and looking to do on triggers. They are a large topic, but they provide an incredible amount of power. What I will try and do, if I can organize it, is I'm going to, actually let me just have a look here, because I think you can download these yourself. If you go to the AdZero Optima website, because if you can download these between now and Thursday, you can have a look at them, and maybe you can send me some questions. News, white papers. Sorry, it'll be under the open source section. Yeah, here we are. There's a whole lot of stuff under DB2 triggers that you can download. There's a couple of articles on what triggers are all about, and then you've got the sample file, the error log file, trigger templates, the IO server module, the check for legacy module, and the utility service programs. So if you'd like to go in there, right at the end of the recording, you'll find the link, and you can download all the source that I've just shown you, and you can have a look through it in your own time. Please do, if you've got time, because I would like to have as much of a discussion around triggers as is possible to do so, because they are so incredibly powerful. All right. Sorry, Marinus, you'd rather use ILE-RPG.org for what? For the questions. Sorry, I'm just... Sorry, I'm not... Okay. I'm not sure what Marinus is trying to say to me, but they are here. He says rather use the ILE-RPG.org. Oh, okay. That's another link as well, which also has exactly the same stuff and can be downloaded from there as well. Okay, thank you very much, ladies and gentlemen. We'll see you again on Thursday. And we'll do quite a bit of revision over this whole topic. Enjoy your day, and see you Thursday. Bye then.